So we will going to discuss the additional instructions, which is meant for the 16-bit operation. These additional instructions are for the data transfer as well as for the arithmetic purpose. So out of this, we have in the previously we have discussed about the LXI instruction, move instruction, and STAX, LDAX, STA, MVI. All these instructions has been discussed. So let us go with an example of that. This is a kind of instruction LXI, which is going to load the 16-bit number, which is defined within the instruction into the register pair. If the register pair mentioned here is HL pair, so 2050 will be stored in the HL pair. One more thing which is very important, lower byte is considered first, then higher byte is considered. Lower byte will be stored in the lower byte register in the case of register pair, and higher byte number will be stored in the higher order register of the register pair. Now, another example of data transfer is to use the move AM, whose purpose is to copy the data, 8-bit data, from the memory location whose address is present in the HL pair to the accumulator. So before using this instruction, it is must that HL pair must be loaded by the address of the memory location where the data is residing, which we want to transfer it to accumulator. So what we used to do before using this instruction, we use LXIH 2050 so that the HL pair will be loaded by a memory address 2050. And then whenever we use move AM instruction, it will copy the content of the memory whose address is present in the HL pair. The address which is present in the HL pair is 2050. So whatever is the content of 2050, which is F7, and that F7 will be loaded into the accumulator by using move AM. Another instruction is load accumulator indirect. Load accumulator indirect is another kind of instruction in which the address of the data is defined indirectly. And the purpose of this is LDAXB is to copy the data from the memory to the accumulator, which memory whose address is defined in the BC pair. So again, it is a kind of indirect addressing. So before we are going to use LDAXB instruction, it is necessary that BC pair must be loaded by address of the memory from where we want to transfer the data into the accumulator. So that's why LXIB 2050 is done first, and then LDAXB. What it is going to do, it will going to copy the content of the memory, which memory whose address is present in the BC pair, where to the accumulator by using LDAXB instruction. Then we have direct addressing, by which we will be defining the address itself within the instruction, that is LDA 2050. So what it will going to do, it will copy the content of 2050 memory address into the accumulator. So these two instructions, previous two instructions are indirect addressing, and this is an example of a direct addressing. Then we have another instruction which is move MR. Now, till now we are copying the data from the memory to the microprocessor to the accumulator. Now what we want to do, we want to copy the content of we want to store the content of the register into the memory. Again, whenever we say move MR, it is going to transfer the data from the register defined to the memory, which memory whose address is present in the HL pair. So before going to use MR instruction, the HL pair must be loaded by a memory address. So LXI H 8000 has been defined. It means HL pair will have now 80,000. 8,000 means H will be 80, L will be 00. That is what has been. And then if we say move BM, it means what we want. We want to copy the data from the B register to the memory, which memory whose address is present in the HL pair, yani 8000. So whatever is the content of 8000. So whatever is the content of B register, it will be copied into the memory, which memory whose address is present in the HL pair, that is 8000. So 32 will be copied into the 8000 memory location. The second, next is the storing of the data from the accumulator to the memory, but using indirect addressing, that is XTAX RP. So before we are using STAX RP, the RP must be loaded by a memory address by LXID 8000. So what it is going to do, it is going to store the content of accumulator into the memory whose address is defined in the register pair. If I say STXD, STXD means we want to copy the content of accumulator into memory whose address is defined in the DE pair. So before we use this instruction, the DE pair must be loaded by a proper memory address, and for that purpose, we can use LXID instruction. Similarly, now again, these two are the indirect addressing. The STA is a direct addressing, whose format is STA 8000. What does it will do? It will copy the content of accumulator into the memory whose address is defined within the instruction, that is 8000. So whatever is the content of accumulator, ये 8000 पे जाकर के कॉपी हो जाएगा. अगर 8000 पे 8000 अगर एक्यूमुलेटर में मेरे पास F2 है और हमने लिखा STA 8000, तो ये F2 एक्यूमुलेटर से निकल करके ये 8000 मेमोरी लोकेशन पे स्टोर हो जाएगा. Again, we have another instruction which is known as MVI M8-bit. It means we want to copy the data which is defined within the instruction, that is F2, into the memory. Which memory? Whose address is again defined in the HL pair. Now we have an example. We have a program statement in which we want to transfer the data in the block. There are 16 bytes of the data which are stored in a 16 memory location, and we want to transfer the entire block to new memory location starting with 8070. So let us understand the problem first. We have 16 bytes which are stored at 16 memory location, and these 16 memory location are represented by 8050, 8051, 8052 and onwards. What we want to do, whatever is this 16 bytes which is stored at 8050 onwards, we want to copy this block of 16 byte of the data to the memory location which is starting with 8070, 8071, 8072, 8073. Meaning thereby, what we want to do, whatever is the content of 8050, it should be copied in 8070. Whatever is the content of 8051, it should be copied at 8071. Whatever is the data of 8052, it will be copied in 8072 and so on. Similarly, 16 bytes of the data will be transferred from one set of memory location to another set of memory location, and for that we have to write a program. So before writing the program, we must know, we must first draw the flowchart, which will be giving you the step-by-step procedure, the process by which you are able to solve this problem, that is the block transfer of the data bytes. So we will start, and after starting, what we are going to do, first of all, we will set up the memory pointer, means the source register, source memory location. We should know, अगर हमको एक जगह से डेटा दूसरी जगह कॉपी करना है, तो हमको मालूम होना चाहिए कि कौन सा स्टार्टिंग एड्रेस है जहां से हमको डेटा मिलेगा और कौन सा डेस्टिनेशन एड्रेस है जहां पे हमको डेटा को लिखना है. So both of this must be known to us. So that is why it is necessary to initialize the memory pointer for the source, as well as we have to initialize the memory pointer for the destination. Meaning that first of all, we will load a register pair by source memory address, and then we will again initialize another source and another register pair by the destination address, that is 8070. As well as we have to set up the byte counter, means how many bytes have to be transferred. If we have to transfer 8 bytes, so it means there will be a loop which will be running 8 times only, and then program will be going to finish. If we have to transfer 10 data bytes, so the loop will be executed 10 times, and then it should finish. So that is why it is necessary to set up a counter which will be showing that how many data bytes are available. Then what we are going to do, we will first read the data byte from the source, and once we are able to read the data byte from the source, then we will store that data byte at the destination. And by doing that, what we are going to do next, we are going to increment the source pointer register by 1, source pointer by 1, as well as destination pointer by 1. And once one of the data byte is being transferred, we are going to reduce the count by 1. Why it is being done? When we are going to read the first data from 8050 and it is being stored at 8070, now you are in requirement to read the data from 8051, and then whatever you are going to read from 8051, it should be copied at 8071. So that is why this source pointer must be incremented by 1, as well as the destination pointer should also be incremented by 1. And why the count is going to be reduced by 1? Because once you are able to transfer one of the data, it means out of the 16 counts, you have done one count. So you are remaining with the 15 counts. So that is why we are going to reduce the count by 1, decrement the count by 1. And then we are going to check. Now this process is being repeated. Just read the data byte, store, increment, decrement. You get the data byte, store the data byte, and this process is being repeated till the counter is going to become 0. Once all the 16 bytes are being transferred, then only this program will be going to finish end. Otherwise, till it is not going to, the counter is not going to 0, it is repeated the number of times. So this number of times it is being repeated. This loop will work till the count becomes 0. So if the count value is initialized by 16, and one by one it is being reduced, in the one loop it will become 15, next loop it will become 14, next time it will become 13. At time will come when it will become 0. Once it will become 0, it means all the 16 bytes have been transferred, and we will going to end the program. So now we have to write the program. This is the flowchart. We are going to write the program. First of all, we have to initialize the memory pointer for the source. Now the source address is given 8050. So whatever I have done, LXIH, HL pair is being used to store the source address of the memory where the data is residing by 8050. यहाँ पे XX लिखा हुआ है, it means you can use 8050, you can use 9050, you can use A050, whatever you want. So LXIH 8050. So what this instruction is going to do, it will going to copy 8050 into the HL pair. The next step is to set up the memory pointer for the destination. Destination has been given as 8070. So we will using another register pair, D pair, for storing the destination address, that is 8070. So 8070 will be stored in the D. And then we have to set up the byte counter. Since there are 16 counts, there are 16 number which has to be transferred. We have to transfer 16 bytes. So we will, the 16 is a decimal number. So the hexadecimal representation of 16 decimal is 10. So we are using B register for storing the count, working as a counter. B register is working as a counter. Now, the next is to get the data byte. Means you have to read the data byte. So you will be reading the data bytes into the accumulator from the memory. What this instruction is going to do, it will copy the data from the memory to the accumulator, which memory, whose address is present in the 8050. So 8050 पे जो पहला डेटा लिखा है वो कहाँ आ जाएगा, accumulator में आ जाएगा. And then what we are going to do is store the data byte. Store the data byte means whatever is the content of accumulator, it will be copied to the memory location where the address is defined in the D pair. तो हमने 8050 से डेटा पढ़ के accumulator में रखा, और accumulator का जो डेटा था उसको 8070 पे ट्रांसफर कर दिया. यानी 8050 से पढ़ा और 8070 पे हमने ट्रांसफर कर दिया. And then source pointer is incremented, so INXH. Destination pointer is incremented, so INXD. So whenever we increment the HL pair content INXH, what will happen? HL pair will become previous value of HL pair was 8050. Now whenever we are going to do INXH, HL pair will become 8051. Similarly INXD, D previous value D pair की value जो है 8070 है. जब INXD करेंगे तो it will become 8071. यानी it will be incremented by 1. So the next time the data will be read from 8051 and it will be stored at 8071. And so we are going to decrement the content of B. B is 16 here, decimal mein, and now it will become 15. And then jump on no zero. Uh, Now, whenever we are going to decrement the content of B, it was 16, it becomes 15. So it is not a zero. So since it is not a zero, so it will jump on no zero. Since zero is not set, zero flag is not set, so it will go to the next. What is next? It will come to the move AM. As since it is no, no is coming to get the data byte. So get the data byte. Now, in this case, it will copy the content of memory into the accumulator, which memory, whose address is in the HL pair. HL pair में अब क्या है? 8051. So 8051 का डेटा अब accumulator में आ जाएगा. और अब क्या होगा? एक्यूमुलेटर में जो 8051 का डेटा है वो कहाँ कॉपी हो जाएगा? टू द मेमोरी whose address is defined in the D pair. D pair में अब क्या है? 8071. सो 8050 का डेटा पढ़ा गया और 8070 पे कॉपी हो गया. फिर हमने सोर्स पॉइंटर को बढ़ा दिया, डेस्टिनेशन पॉइंटर को बढ़ा दिया, फिर काउंट को हमने कम कर दिया 1 से, और ये प्रोसेस इस तरह से रिपीट होता रहेगा जब तक कि जीरो फ्लैग सेट नहीं हो जा रहा. तो इस तरीके से पहला डेटा ट्रांसफर करेंगे, दूसरा डेटा ट्रांसफर करेंगे, तीसरा डेटा. जब 16 डेटा ट्रांसफर हो जाएगा तो डिक्रीमेंट जब बी करेंगे तो बी की वैल्यू 0 हो जाएगी. जब बी की वैल्यू 0 हो जाएगी तो जीरो फ्लैग सेट हो जाएगा. तो जीरो फ्लैग जब सेट हो जाएगा तो ये जंप तभी करेगा जब तक नो जीरो है. तो जीरो फ्लैग जब सेट हो गया तो ये कहाँ चला आएगा? हॉल्ट पे आ जाएगा एंड इट विल स्टॉप. Okay. Now, the actual part is taking place here. You see, in the HL pair, it is 20. In the HL pair, it is 2050, and the memory location 2050 is 37. Actually, the example which has been taken from 8050, but the figure which has been taken, it is from 2050. It hardly matters. You consider that instead of it is 8050, consider it as 2050 and consider it as 2070. Then only it will be applicable. So first of all, HL pair में 2050, D pair में 2070. अब हमने क्या किया? मूव AM. तो 2050 पे जो कंटेंट है 37, ये कहाँ आ गया? एक्यूमुलेटर में आ गया. उसके बाद हम कह रहे हैं STXD. तो STXD जब कर रहे हैं तो D पेयर में है 2070. तो ये जो एक्यूमुलेटर का कंटेंट है 37, ये 2070 पे कॉपी हो जाएगा. यानी 2050 से आपने पढ़ करके एक्यूमुलेटर में डाला और एक्यूमुलेटर से आपने 2070 पे कॉपी कर दी. सो इन दिस वे, दिस इज द illustration by showing the figure that how the data is being read from the source and how it is being stored at the destination. Now, there are arithmetic operations which are related with the memory, as discussed earlier also. We have 4 such instructions: add M, subtract M, increment M, and decrement M. Add M, it will going to add the content of memory with the content of accumulator and store the result in the accumulator. Now again the question is, which memory? The memory whose address is present in the HL pair. Similarly, subtract M, it is going to subtract the content of the memory from the accumulator and they store the result in the accumulator. Which memory? Whose address is present in the HL pair. INR M, it is going to increment the content of the memory by 1. Which memory? Whose address is present in the HL pair. Decrement M, it is going to decrement the content of the memory. Which memory? Whose address is present in the HL pair. So all these 4 instructions are the arithmetic operation instructions which are related to the memory and comes under the additional instructions. Now, the pictorial illustration of these instructions has been shown. If we are saying that add M, so what will happen? It means accumulator is already having some kind of data. So, and HL pair is having 2040. So whatever is the content of 2040, that is 68, that 68 will be added with the content of accumulator, that is 30. 68 is added with the 30 and will give 98 in the form of a result, and this result will be stored in the accumulator itself. Similarly, you have to subtract. So subtract M. So what it will do? It will subtract the content of memory, which memory whose address is present in the 2041. So the 2041 content is 7F. So 7F will be subtracted from the content of accumulator. That is 98 is subtracted from 7F to get the value 19. And this 19 will be stored in the accumulator. So this is again an illustration how the INRM is going to work. Whenever I say INRM, it is going to increment the content of memory. So which memory whose address is present in the HL pair? तो HL pair में अगर 2040 है और HL pair में 2040 और 2040 is the address of a memory. इस memory पे हमारे पास 59 अगर data है तो क्या होगा? What it will do? INRM will increment the content of 2040 by 1, means 59 is added with 01, so that the result will be getting 5A, and this 5A will be stored in the memory itself. Similarly, if we have to use the decrement M, so what will happen? Whatever is the content of memory whose address is defined in the HL pair, that is 2041, the memory content is 90. 90 is decremented by 1, subtracted by 1, so that it will become 8F, and this 8F will be stored in the memory location. Now I'm going to give the illustration of adding many data bytes stored in the memory and want to store the result. Meaning thereby, if we have 10 numbers or 5 numbers or 6 numbers or 8 numbers, and we have to add all these numbers, how we will be doing the program. So before drawing the flow chart and writing the program, let us discuss that what is the requirement of the problem. We have to add many data bytes which is stored in the memory, and we have to store the result. Now, so how many data bytes are to be stored? This must be known. And based on that value, we will set up a counter, a count value. If we have to add 10 data bytes, so we have to initialize the counter by 10. If we have to add 5 data bytes, so initialize the counter by 5, and so on. Then second point is the data which will be added will be somewhere stored in the memory location. So what are those position? What is the indexing? What is the address where the data has been stored, which is required to be added? So you have to set up a pointer, memory pointer. Then once you set up a pointer, once you set up a counter, you will transfer the data into the microprocessor and then perform the addition. And after performing the addition, you have to store the temporary result, because whenever it is asked you to add 10 numbers, so what you will do? You will take the first number, second number, add it. Whatever you are getting in the form of a result, that result will be added with the third byte, third number. Whatever is the result, it will be added with the next number. Whatever is the result, it is added with the next number. So in this way, we are going to add. So after adding each two number, it is required to store the temporary result for the addition process. And it is also possible that whenever we are adding two 8-bit numbers, it is not necessary that the number will remain as 8-bit. There is a possibility that the number might be of 16-bit, because there is a generation of carry. So if there is a generation of carry, you have to take that part also into the account. And once you are going to check the flag and indicate the completion of the task, then you have to store the final result. So this is the program. This is the problem statement in which we have 6 data bytes are stored in a memory. You have to add all data bytes, use register B to save any carry generated, and display the entire sum at 2 consecutive memory locations. So we have 6 data bytes. So first of all, we will take the first data byte, we will take the second data byte, add together, and we'll check whether the carry is generated or not. For storing the carry, we will be using a register by initializing it as 00. If the carry is generated, we will increment the content of that carry register by 1. And so temporary result will be stored somewhere else, then the sum will be added with the third number, and so on. So with this process we will go on. So let us first discuss the flowchart. So we'll start, and we will clear the register to save the sum. Now sum, for storing the sum we will be using accumulator. So it has to be clear, because there is a possibility by before you write your program, before you execute your program, there is a possibility that accumulator will have something. So before, just for any accident, that accumulator should be cleared, the sum value should be cleared, because until unless you are not going to add the data, you are not going to get the result. So whatever is the previous value of accumulator, that should be abolished, that should be reset by 00. Then again we have to save the carry also. कैरी बिट को भी हमको स्टोर करना है, तो उसके लिए एक रजिस्टर हम इस्तेमाल करेंगे जिसमें हम कैरी स्टोर करें, तो उसको भी हम लोग इनिशियलाइज कर लेंगे. तो इसका मतलब 2 रजिस्टर हम लोग यूज कर रहे हैं, एक सम को स्टोर करने के लिए और कैरी को स्टोर करने के लिए. उसके बाद हम काउंटर सेटअप करेंगे, माने इंडेक्सिंग करेंगे मेमोरी पॉइंटर जहां पे हमारा डेटा है, और काउंटर सेटअप करेंगे कितने डेटा बाइट्स को हमको जोड़ना है, 2, 4, 8. तो इस एग्जाम्पल में 6 डेटा बाइट को जोड़ना है, तो काउंटर हमारा 6 से इनिशियलाइज होगा, और पॉइंटर वो पॉइंटर है जो कि बताएगा कि हमारे मेमोरी लोकेशन पे कहाँ पे डेटा लिखा हुआ है. देन वी विल स्टार्ट विद सम इज इक्वल टू सम प्लस पॉइंटर. सम इज इक्वल टू सम प्लस पॉइंटर मीन्स सम हम लोग एक्यूमुलेटर में स्टोर कर रहे हैं, और एक्यूमुलेटर की प्रीवियस वैल्यू 0 है. सो एक्यूमुलेटर विल बिकम 0 प्लस पॉइंटर. पॉइंटर का मतलब जो पहला डेटा है, पहले डेटा को हमने 0 के साथ, जो सम की वैल्यू थी उसके साथ जोड़ दिया, यानी पहले डेटा को हमने जोड़ दिया. उसके बाद हम चेक करेंगे, okay. So what we are going to do, we are going to sum is equal to sum plus pointer. Let us discuss first the flowchart only. Sum is equal to sum plus pointer. Pointer means the first data. Sum means the previous sum. Then we'll check whether there is carry generated or not. If there is no carry, then we will skip. If there is a carry, then we will increment the content of the carry register. जिसको हमने carry register बनाया, that will be incremented by 1. अगर कैरी जनरेट नहीं हो रहा है 8 बिट को जोड़ने से, तो वी विल स्किप दिस प्रोसेस, एंड अगेन वी विल कम टू द नेक्स्ट नंबर को जोड़ना है. सो पॉइंटर इज इक्वल टू पॉइंटर प्लस 1, एंड काउंटर विल बिकम काउंटर माइनस 1. मींस एक नंबर आपने जोड़ लिया. अब आप चेक करेंगे कि काउंटर 0 तो नहीं हो गया, सारे डेटा बाइट्स जुड़ गए हैं कि नहीं जुड़े हैं. अगर सारे डेटा बाइट्स नहीं जुड़े हैं, सो इट विल से नो, एंड व्हेनेवर इट विल से नो, इट विल गो बैक, And then sum is equal to sum plus pointer, means the next number will be added with the previous sum. Again, we will check carry is there or not. If carry will be incremented. Otherwise, pointer will be incremented and counter will. And this process, this looping process, this uh, uh, repetition of the process will go on until the counter becomes 0. Meaning thereby, when all the 6 bytes will become 0, then it will not go back. It will say yes, and then it will display or save the sum. So let us now go and discuss about the program. So to clear the sum register, we are using sum register as accumulator. So whenever we are using an instruction XRA A, whatever is the previous value of A, we are going to do the XOR operation with the content of A. So whenever we are going to do the XOR operation with the same content, we will getting 0. So it means accumulator will be cleared. It will become 0, 0. And this 0 will be copied in the B register, because B register will be used to store the carry. And C is used as a counter. So there are 6 numbers, so 6 will be loaded in the C. And pointer is 8050 or XX50, so 50 is loaded in the HL pair. Then we are going to add M. So the content of accumulator will be added with the first data byte. When the content of accumulator is added with the first data byte, and the content of previous accumulator is 0, 0, so the first data byte is added with the sum. So the next new value of sum will become the next data byte. Jump on no carry. अगर carry generate नहीं हो रहा है, because if there is no carry, then it is skipping this process. लेकिन अगर carry generate हो रहा होगा, so it will increment the content of D. अगर carry generate नहीं हो रहा है, तो ये सीधे यहाँ आ जाएगा next memory पे, जो कि है pointer को बढ़ा देगा INXH, counter को decrement कर देगा DCRC, and this counter, whenever it is being decremented, it is checked whether the 0 flag is set or not. Since 0 flag is not set, so it will go to the next byte. Again, it is going to add M. Now, the previous sum, which is stored in the accumulator, will be added with the next number. And so this process will go on. And once the decrement, it will be decremented. Last time, all the 6 data bytes has been added. Then decrement C करेंगे तो value 0 हो जाएगी. जब 0 हो जाएगी तो jump on no 0 नहीं होगा. Jump on 0, 0 flag set हो जाएगा. It will go and store the result at the port number 1. पोर्ट नंबर 1 पे सम की वैल्यू सेव हो जाएगी, क्योंकि एक्यूमुलेटर में हमारा सम है. उसके बाद बी रजिस्टर में हमारा कैरी है, जो कि एक्यूमुलेटर में ट्रांसफर करेंगे, और एक्यूमुलेटर में ट्रांसफर करने के बाद इसको आउटपुट पोर्ट 2 पे ट्रांसफर कर देंगे. तो सम और कैरी की जो वैल्यू है, जो कि 16 बिट नंबर के फॉर्म में है, दैट विल बी कॉपीड इनटू द डिफरेंट पोर्ट्स. सो इन दिस वे this is going to